Okay, you can start now, sir.
Okay, there's something on my side here now. Good morning, boys and girls. With you today, it's Mr. Sibanyoni, and I'll be taking you guys for Physical Sciences, grade 12. And for today, we are definitely going to deal with paper 2. We are dealing with organic chemistry, a very important topic, and it counts a lot of marks. It is plus minus 48 to 60 marks in your final examination paper for grade 12. So we need to make sure that we understand the topic very, very well. And that is exactly what we are going to deal with. And I have carefully selected questions that are going to test quite a lot of concepts in nomenclature, and it will bring you different angles with which you need to understand this topic. So feel free to send me questions, and I will be checking the comments out in our chat box for any questions of clarity, and be guaranteed that I'm definitely going to give you a great feedback with regards to anything that you are asking. So I'm really glad that you have joined us. Please make sure that you have a pen and paper so that you are able to take down notes and you are able to work with me. Right, without wasting any time, I'm going straight into the content. Right, now, you must be having your Bible, and that Bible is called the Examination Guidelines. Now, in your examination guidelines, it gives you everything that you need to know for each and every topic in physical sciences that is going to be examined. And therefore, it is very critical, my dear learners, that you have it, because it has all the definitions for each topic and the definitions that we want you to write in your examination paper at the end of the year, because these are the only definitions that we are going to accept, and not necessarily definitions from the textbook. So use your examination guidelines for all of that. Right. We are only looking at nomenclature, and I just want to remind you what is really critical in this topic. So we must be able to define the term organic molecules. Very critical, and those are molecules containing carbon atoms. So this definition is very important, and it will be for 2 marks if we ask you. And remember, it's 2 or 0. In other words, you can't get a 1 out of 2 altogether. So you need to give us the definition as it is, making sure that all the keywords are there in your particular definition. So that is very important. Now, we look at organic molecules, the functional groups, and molecules that are saturated and unsaturated, as well as isomers. That is what we learn in nomenclature. So for all these homologous series here, right, that we have learned, we must be able to write down a structural formulae for any molecule that we are given. We must be able to write a molecular formulae. Also, we must be able to draw a structural formulae for any molecule in this homologous series. And remember, we must also be able to give Iupac names. And you know, here we have a system of naming. We have rules that we apply when we want to give names. Now, make sure that you don't work with molecules that contain more than 8 carbons in the parent chain, because that is not going to be examined. The parent chain must be at a maximum of 8 carbons, which is oct. But remember, you might still have substituents. In other words, the number of carbon atoms can still be 8, but the parent chain must not be more than 8 carbons. Once more, my dear learners, these two homologous series, the haloalkanes and the alcohols as well, remember, we must be able to identify a primary haloalkane or alcohol, a secondary haloalkane or alcohol, and a tertiary haloalkane or alcohol when we are given a structural formulae. We must be able to do that and to give reasons why we say this haloalkane is primary or secondary or tertiary. So that is very critical, and the same applies to alcohols. But also, we might be required to draw the structure of a given alcohol when we are giving clues that it must be primary, secondary, or tertiary. When we are also dealing with organic reactions. So very critical for you to be able to work with that, right? I move further. I talked about this. We must be able to draw structural formulae. Remember, with structural formulae, you need to show us all the atoms and the bonds between the atoms. So it shows which atom is bonded to which, right? And the bonds are there. And then with your condensed structural formulae, remember what you are going to do. You are not going to show us the bonds. With a condensed structural formulae, this is not shown. Can you see there? We do not have bonds. Now, when you are given a condensed structural formulae, normally I've noticed that learners, you tend to struggle with this if you are given questions either in physical properties, in organic reactions. You'd rather turn it into a structural formulae. You'd rather turn it into this, the structural formula, because that's easy for you to work with. You can see which atoms are where and the bonds between those atoms. But remember, a condensed structural formula is really more important if we ask you to write down that condensed structural formula for a given molecule, for example, for butane. Or if we ask you to give an Iupac name of a condensed structural formulae. So if it is given like this, you can just turn it into a normal structural formulae and you'll be able to work it out. So be able to interpret condensed structural formulae or write them down. And here there are two ways that you could show it. Can you see the oxygen there? It is shown that the carbon has a double bond oxygen, so that is definitely acceptable. Other important definitions is the definition of a hydrocarbon and the definition of the homologous series. You must be able to define that, right? And we'll be dealing with all these definitions in between the questions as and when we are being asked that. Furthermore, again, on the section of nomenclature, you must be able to define the term saturated compounds. And I need to just mention, my dear learners, sometimes We don't refer to compounds, we refer to molecules. We refer to molecules. So you must know that when we refer to a compound in organic chemistry, we are referring to molecules. So do not be surprised if an examiner said, define the term saturated molecule. You must know it's still the same as defining saturated compounds and also defining the term unsaturated compounds. And also a very critical definition is the definition of a functional group. Very important definition, because when you understand that a functional group is a bond or an atom or a group of atoms that determine the physical and chemical properties of a group of organic compounds, then you will also be able to understand the next section, which is physical properties. And furthermore, Iupac naming of compounds. And there we have all the rules that you need to apply when you name organic molecules, and we are going to apply them as and when we do the question. So what I'm basically trying to show you here, my dear learners, is that you go to examination guidelines, you get the most correct definition, 100% correct definitions, and you get clues as to what is going to be examined. Right. Now, we move to questions. Now, I want us to practice working with multiple choice questions. It is very important for us to be able to work with multiple choice, because it's going to be 20 marks of our question paper. So we must practice how to deal with that. So I want to also skill you as to how can you deal with these molecules when you are being asked questions on them in organic chemistry and multiple choice. Right, you are given a question here. They say, consider the organic compound represented below. So here is a molecule. There is something special that I already see there. I see that there is a double bond between the two carbon atoms. Already, without going anywhere, I can already say this molecule belongs to the homologous series alkenes. Right? That is already what comes into my mind when I just look at the molecule before I even go into the questions, or rather into the options that are given. And already, if I see that it is an alkene, I already see that the double bond means that I have a multiple bond, right? It is not a single bond there between the carbon atoms. It is a multiple bond. And when I have a multiple bond, I already know a multiple bond between carbon atoms. I already know that the molecule is unsaturated. Altogether, it is unsaturated. Right. And what else can I see in this molecule without going anywhere? Is that I can see there, my dear learners, I have a substituent. I have a substituent. In other words, when I have a substituent, I know that it means I have a branch. I have a branch. Right. Now I've examined my molecule. Now I go to the options. They say the compound is, I'm going to choose any letter from A, B, C, and D. Saturated and branched, already saturated. I know that it is wrong. Why? Because saturated compound is organic molecules that contain only single bonds between carbon atoms. So this cannot be correct because I have a double bond there. Branched, yes, branched is there. It's fine, but the fact that they said saturated, that means this is wrong. Then I go to option B. Option B, unsaturated. Yes, it is unsaturated. We've already talked about that. And then branched. Yes, it is branched. I have a branched. It means my correct answer is option number B. All together. And we don't have to go further because all these two apply to the molecules. This one already see it wrong because of saturated. Even straight chain is wrong because there is a branch. Unsaturated for option D is correct, but you see the straight chain part is wrong because there is a branch. So the correct answer is option B for 2 marks. Then another question here, a structural isomer of butane is, and I'm giving these options: A, propane; B, 2-methyl-butane; C, 2-methyl-propane; D, 2,2-dimethyl-propane. Now, we need to remember what structural isomer is. Those are organic molecules with the same molecular formula, but different structural formula. So the molecular formula must be the same. Now, before we can even work with this question, we need to know what is the molecular formula of butane. So the molecular formula of butane, for me to work it out, I can quickly just draw butane for you. Perhaps this one will make it easy instead of working with a general formula. All right. Remember, but means 4 carbons, 1, 2, 3, 4. And then ane means that it is an alkane. So it must be single bond between carbon atoms and only hydrogens. Then I put my hydrogens there, hydrogen there, hydrogen there, my hydrogens, there are my hydrogens. Hydrogens. Right, capital letter hydrogens. Then if you go and count the number of carbons, we can see it's 1, 2, 3, 4. It's 4. And then it's hydrogens, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's C4H10. Remember, any molecule here from A to D that is going to be an isomer, it must also be a C4H10. So let us test. Propane, prop means 3 carbons. So this molecule will have 3 carbons. It will be wrong because the molecular formula will not be the same as butane. Butane has 4 carbons. Then option B, I have 2-methyl-butane. So the math tells me there is 1 carbon in the substituent. The but means there are 4 carbons. So in total, I'll have 5 carbons. So this will not be an isomer because butane has 4 carbons. So option B is wrong because this molecule in total will have 5 carbons. Option C, 2-methyl-propane, the math part tells me that I have 1 carbon. The prop part tells me that I have 3 carbons. So in total, it has 4 carbons. So I can actually suspect that this one is correct. And let us try and draw it. So 2-methyl-propane, the longest chain without breaking is prop, 3 carbons. 1, 2, 3. So I'm starting with the parent chain, 3 carbons. And then I see I have a methyl substituent and it's on carbon 2. So if I number my carbons 1, 2, 3, it means on carbon number 2, I must put a methyl, meaning it's a substituent with 1 carbon meth. Then I put my hydrogens, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my hydrogens. Right, that one doesn't look neat. It's my eraser. There we go. And my pen again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I made sure that again around each carbon I have 4 bonds. So if you look at this molecule 2-methyl propane, it is also 4 carbons and 10 hydrogens. Can you see that butane, which is this one, and 2-methyl propane, they are organic molecules with the same molecular formula, but the structural formula is different. So they are structural isomers, 2 marks. And I need not go further, but option D was going to be wrong because dimethyl means 2 methyls. So it's 2 carbons prop, 3 carbons. So I would have a total of 5 carbons. So it would not qualify as a structural isomer. Then we go further. They say which one of the following compounds represents a ketone? Remember, a ketone must have a carbonyl group. And the carbonyl group, you must get it between 2 carbon atoms. So let us look at option A. And remember, carbonyl group is exactly the C double bond O. And this C double bond O is between this carbon and this carbon. So it's between these 2 carbon atoms. So this is definitely a ketone. Option B, not a ketone. Remember, with ketones, we also deal with 1 oxygen. So B is wrong. It has 2 oxygens. Furthermore, by just examining it, my dear learners, we can see that this option B belongs to an ester. We want a ketone. And then if you look at option C, it has C double bond O with an OH. So this part is a carboxyl group. So C is a carboxylic acid. And then when we deal with option D, we can definitely see that this one is an alcohol. So the correct answer is option A. It's a ketone. Then consider the compound with molecular formula C4H10. How many structural isomers does this compound have? And I want us to just go back to the previous slide. C4H10 is this molecule. It's butane, right? It's butane. So C4H10, they're referring to butane. And also another C4H10, it's this one. 2-methyl propane. So C4H10 comes in 2 forms, my dear learners, in this form and in this form. And these 2 forms are the isomers because the forms have different structural formula. So it's this form and this form. And therefore, the answer must be here, which is 2 isomers. Now, what I often see is that learners make mistake. They will say it only has one isomer. Remember, the number of structures, the number of structural formulae that you can get for a molecule is the number of isomers that the molecule actually has. Right. We go further. Which one of the following compounds cannot be an alkene? Now, my dear learners, you must know that when you are given a molecular formulae, so we want, let me start it here. We want a molecule that cannot be an alkene. It means all of them are alkenes, but only one is not an alkene. So for you to work with that, you must remember when you have a molecular formula, you can actually start thinking about a general formula, because normally we use a general formula to determine a molecular formula. Now, the general formula for alkenes, we know it's CnH2n. Are we together? So any molecule that is not defined by this general formula, then it is not an alkene. And we know the N stands for the number of carbon atoms. So let us try A. If the number of carbons is 2, if I put 2 there and I put 2 there, it means I'll have C2, and then I'll have 2 times 2 on the H, it's 4. So this is definitely an alkene. Let us go to B. The number of carbons is 3. So where I see N, I substitute 3. So it will be C3, H, 2 times 3, H6. So this is definitely an alkene. I go to option C, C3H8. So the carbons is 3. If I put a 3 on the N, it's 3. 2 times 3, it's 3, it must give me a 6. But check there, I have an 8. So this molecule on option C is not determined, it's not defined by this general formula of alkenes. And therefore, this is the correct answer, because this cannot be an alkene. Then we go to the next question. Which one of the compounds represented below is an unsaturated hydrocarbon? Now, just to go back, remember, if it is unsaturated, we are going to see what? A multiple bond between carbon atoms. Very important, not just multiple bond, a multiple bond between carbon atoms. So I'm just going to look for a molecule here that has a multiple bond between carbon atoms. And the molecule here that has a multiple bond between carbon atoms, if you just quickly examine all the answers, it will be B. And that is going to give us 2 marks altogether. Double bond between carbon atoms. Not the double bond between the carbon and the oxygen. No, not the double bond between the carbon and the oxygen. It must be unsaturated because of the double bond between the carbon atoms. Right. Furthermore, consider the 2 organic compounds represented by 1 and 2 as shown below. There are the molecules 1 and 2. They say which one of the following correctly represents the homologous series to which each belongs. Remember, homologous series, it's like your family, the family that they belong to. It's just that we have a scientific term for that, and we say it is homologous series, right? Molecule 1. Remember, if you want to determine, firstly, to which homologous series a molecule belongs, you need to determine its its functional group. So the functional group here, I can see it is a carbonyl group And not just the carbonyl group, I get it between this carbon and I get it between this carbon. So this one becomes a ketone. So I just check my options quickly. One is a ketone. Already their option A is wrong because they say it's an aldehyde. B is wrong because they say it's an aldehyde. It means my answer lies between B and C. Then I go to option 2. To molecule number 2, I see what I see is carbon double bond oxygen, and it's only on one carbon atom. So this is the first carbon and the only carbon atom. And therefore, this is then our functional group, and we call it a formyl. We call it a formyl. There we go. We call it a formyl group. That is the name of the functional group of aldehydes. So this molecule belongs to aldehydes. So I check between B and C. Ketone, yes. Aldehyde, yes. So the correct answer must be C. And B cannot be because this is not an alcohol. Can you see this is not an OH? It's not a hydroxyl group. So that is that in terms of multiple choice questions. Now, let us go to structured questions. Right? Question number 2. The Iupac name of an organic compound is 4,4 dimethyl pent 2I. So there we've been given an Iupac name. This molecule, they ask us questions. They say, write down the general formula. Now, my dear learners, this is in capital letters. It means you need to take cognizance of it. They say, write down the general formula of the homologous series to which this compound belongs. Remember, each homologous series has its own general formula. And I can see that this molecule belongs to alkynes. And this is recall work, my dear learners. It's level 1 question. You must know it off by heart. The general formula of alkynes, it's CN subscript N H2N minus 2. And they must be written nicely. I often see mistakes where a learner would write CNH2N minus 2 like this. It can't be like that. These ones are subscripts. So it must be like that. And that is 1 mark. 2.1.2, write down the structural formula of this compound. My dear learners, drawing a structural formula is very easy because you just have to interpret what has been given on a name. Now, if you look at this name, firstly, underlined here is the parent chain, and then what I have encircled there, we call it the substituent. So every time you draw a molecule, you have to start with the parent chain. And they said a structural formula, not a molecular formula, not a condensed structural formula. It means I must show all the atoms and I must show the bonds between the atoms. So I'm going to start with the parent chain, the one that is underlined. I analyze this. It's written pent, and pent means 5 carbons. So I go 1, 2, 3, 4, 5. Right. Then it's written YNE. So the name ends with why, and it ends with "-ine." It means this molecule belongs to alkynes, and we know alkynes, they have a triple bond between carbon atoms. And this two gives us the position of that triple bond because it is the functional group. So if I'm numbering from left to right, let's say this is carbon 1, this is carbon 2, and please don't include the numbers when you are drawing. It is just for the purpose of this lesson so that you see clearly what I'm doing. So on carbon 2, my dear learners, I must have the triple bond. So I had just made it a single bond. I'll put the second one, the third one. So there I have a triple bond. So this is pen-2-ine. Now I go, my dear learners, and I include my substituent. So my substituent is methyl, but the dye tells me that it's 2 methyl substituents. And these numbers here are telling me that the methyl substituents are on carbon number 4. So I'll go on carbon number 4. I'll put the methyl substituent. Meth means 1 carbon. I'll go again on carbon number 4. I must put another methyl substituent. And the only thing that is left is for me to put my hydrogens. And please make sure that around each carbon atom you have 4 bonds. So if you look at carbon 1, it's 1 bond so far, the second one, the third one, the fourth one. If you look at carbon number 2, it's 1 bond, the second bond, the third bond, the fourth bond. So it's full. If you look at carbon number 3, it has 1, 2, 3, 4 bonds. So it's full. So my hydrogens are only going here. Go together. Right. And learners tend to forget the hydrogens. Always make sure that you do this, my dear learners. And you will get 1 mark for the functional group, correct? You will get 1 mark again for the parent chain, as well as your substituents being in the correct position. So that was an easy 4 marks. Then we go to the next question. The organic compound below has 1 positional isomer and 1 functional isomer. Right, so that's information that has been given to us. So they say this molecule has 1 positional isomer and 1 functional isomer. By just looking at the molecule, I can already see a carbonyl functional group between 2 carbon atoms. So this molecule is a ketone. Then we are asked to define the term positional isomer, right? Right? Now, positional isomer, those are organic molecules with the same molecular formula, but different position of functional group. So organic molecules with the same molecular at different position. And I want you to take down this definition, my dear learners, a different position of the functional group. Sometimes we also include side chain and so on, and I don't want to complicate it for you. If you give us this definition, you will get all your 2 marks. And this definition makes it easy for you to work with positional isomers. Right. My dear learners, quickly examining this definition, they must have the same molecular formula, but the position of the functional groups must be different. Now, if you omit the word position, you are going to lose marks, because if you omit the word position, it will read at different functional groups, and that will be wrong, because now when the molecules start to have different functional groups, then we are referring to functional isomers. So it's a different position of the functional group. Then they want us to write down the Iupac name of its positional isomer. This is in capital letters. This always in capital letters. So if you understand the definition, it means I must examine this molecule that has been given, and I must draw another molecule, but this functional group must go to a different position. So if I follow Iupac rules, this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and this is carbon 5. So it must have the same molecular formula, but the position of the functional group must be different. It means this functional group can no longer be on carbon number 2. It has to be on carbon number 3 altogether. So what I'll do is, I wanted the Iupac name. Now, if I want the Iupac name, I can't give the Iupac name if I don't know how the molecule looks altogether. So the molecule would look like this. 1, it must still have 5 carbons. Remember, the molecular formula must be the same. But what I'm going to do now is I'm going to move that carbonyl group, and I'm going to put it on carbon number 3. This is carbon 1, 2, 3, 4, 5. And I'll make sure that around each carbon I have 5 bonds. So this will be the second, the third, the fourth bond. 1, 2, the third, the fourth. 1, 2, 3, 4. So there is nothing there. Carbon 4, 1, 2. So I'll put 1, 2 to make it 4. This one has 1. This will be 2. This will be 3. This will be 4. Now, if you look at both the molecules, as I'm busy writing the hydrogens, you will see that they all have 5 carbons, and they all have 10 hydrogens, and they all have 1 oxygen. So this is C5H10, H10O. The oxygen is isolated. There we go. My pen, there we go. If you look at this molecule again, it is also C5H10O. Can you see that these 2 molecules have the same molecular formula? They're both C5H10O, but the position of the functional group is not the same. There it was on 2, that it was on 3. But all they wanted was actually the Iupac name. So this is just your rough work. Then, if we give Iupac names, remember we follow Iupac rules. The longest chain without breaking, which is the parent chain, is 1, 2, 3, 4, 5 carbons. So it will be a pent, right? And remember, we must have our connector there. So it's pentan. And then because this molecule is a ketone, we know the name must end with O-N-E. And then I also have to give the position of the functional group. And remember, I always put the position between the prefix and the suffix. So there's the 3. And other Iupac rules means there must be a hyphen between a letter and a number. Between N and 3, there must be a hyphen between a letter and a number. So this molecule is pentan 3-O. Then the last question, they want the structural formula, my dear learners, of the functional isomer. Remember now, when we define functional isomers, we say they are organic molecules with the same molecular formula, but different functional groups. It means if I want a functional isomer of this molecule, I can't draw a ketone again because a functional isomer requires that the molecular formula be the same, but the functional groups must be different. So obviously, it then teaches me, remember with ketones, the general formula is CnH2nO. So the only way that this can be correct, the only way that I can get the correct functional isomer is if I look at another homologous series, but it must also have the same general formula. Because if the general formula of 2 different homologous series is the same, this general formula and this general formula is the same, but the homologous series are different, then I'm going to get different molecules belonging to different homologous series. So this is a ketone, and therefore this is a ketone, and definitely know that another homologous series with the same general formula will be an aldehyde. Right. It means now I must draw an aldehyde. And remember, with an aldehyde, I have a functional group as a formal group on carbon 1. So the molecular formula must be the same. So the number of carbons is 1, 2, 3, 4, 5. So I must still have 5 carbons. And if I have 5 carbons, I'll call this carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. And it's really up to you. This carbon on the left could have been carbon number 1. And remember how we draw an aldehyde, we sit with the formal group, C double bond O on the first carbon. And then I'll be done. All I'll just check is each carbon has 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Put my hydrogens there. This is very nice, very nice. This is where you collect all the marks, my dear learners, in terms of nomenclature. Right. And if you check this molecule again, 5 carbons, so it is a C5. And the number of hydrogens, if you count them, it is 10. And there is also 1 oxygen. Can you see now this molecule and this molecule? They have the same molecular formula. They are both C5H10O, but they have different functional groups altogether. And hence they belong to different homologous series. And this is where your 2 marks was going to come from, right? And I could not leave you without giving you homework. So please look at this one as you go through the recording again, and just take this as your homework and check if you are able to answer all the questions that are on this particular slide. With all of that, my dear learners, I thank you for joining me, and I will see you next week again. Same time, same place. And we are going to continue with more questions on paper 2. So thank you very much for joining me, and enjoy the rest of the afternoon. Goodbye.